Hello, welcome to this lecture on modeling analysis and estimation of three-phase unbalanced power network. In the last lecture, we have stopped here. So, we will continue with this derivation. So, we have essentially looked into the equations for VA, VB and VC. Now, we will look into the equation for the last row. So, in the last row, we have the equation for last row. We have the equation as 0 is equal to ZXA minus ZA. So, ZXA minus ZA into IA plus ZXB minus ZAB, ZXB minus ZAB into IB plus ZXC minus ZSC, ZXC minus ZSC into IC plus ZXX minus ZAX ZAX IX. Now, the current in the phase A is actually IA plus IAX. So, then therefore, I can write it down as ZXA minus ZA into IA plus IX plus ZXB minus ZAB to IB plus ZXC minus ZAC into IC plus ZXX minus ZAX, and I have now added ZXA minus ZA into IX. So, I have to now subtract it. So, then therefore, if I do subtract it, so it will be minus ZXA plus ZAA into IX, right. So, therefore, I can write it down at ZXA ZAA into IA plus IX plus ZXB minus ZAB into IB plus ZXC into IC plus say ZXX dash into IX. So, I say this is actually ZXX dash and this is equation 9. So, now I have got now 4 equations 6, 7, 8, 9. So, now from 6, 7, 8, 9, so from equations 6, 7, 8, 9, we can write the following: VA, VB, VC 0. That would be equal to ZA, ZA, ZAB, ZAC and ZAX minus ZAA, ZAX minus ZAA, then ZBA ZBB, ZBC, and ZBX minus ZBA, ZBX minus ZBA for VC, ZCA, ZCB, ZCC, and then ZCX minus ZCA, ZCX minus ZCA, and the last row is ZXA minus ZAA, ZXB minus ZAB, ZXC minus ZSC, and this is ZXX dash. So this is a matrix, and this would be, this current is IA plus IX, and this is actually IB, IC, IX. Please note that the current IA plus IX is actually the actual current of phasing. Now what we do is we now partition this matrix. So we partition this matrix like this. So partition this matrix like this. This 3 cross 3 matrix we call at ZA, and this 3 cross 1 vector we call is, say, ZB. This 1 cross 3 vector we call is, say, ZC, and this is ZXX, right? And we also write that now IA plus IX is actually IA. So then therefore now we also write another, we also define the vector VABC is equal to VA VB VC, right. So then therefore I can write down this following equation: VABC, that is this, and this is also I partition it. So VABC is equal to ZA into, say, IABC, and I also say that IABC is IA plus IX, IB, IC. So this is also another vector. So IA plus IX, IB plus IC. So I also partition this plus ZB into IX. So this is one equation, and the second equation is 0 is equal to ZC into IABC plus ZXX dash into IX. Correct. So therefore from the second equation I can say that IX is equal to minus 1 by ZXX dash into ZC into IBC, ZC into IABC. Please note ZC is a, let us note it, that ZC is a 1 cross 3 vector and this is a 3 cross 1 vector. So, then therefore, this would be a scalar quantity. Now, if I substitute Ix into the first expression, so then therefore, from here I can write down that VABC is equal to ZA into IABC minus 1 by ZXX dash. Please note that this is a scalar quantity, so I can take it away, I can shift it, then ZB into ZC into IABC. So, or in other words, ZA minus 1 by ZXX dash into ZB to ZC to IABC. Right. So, these I can write that ZABC into IABC, where, so this is the matrix ZABC is given by ZA minus 1 by ZXX dash into ZB to ZC. Now, let us see that what is the expression of ZABC. Now, ZABC, so ZA. So, ZA is this. So, I mean, let us write down. So, ZA, ZAB, ZAC, ZBA, ZBC, minus 1 by ZXX dash ZB. ZB is ZAX minus ZA. So, it is ZAX minus ZA, then ZBX minus ZBA, ZBX minus ZBA, then ZCX minus ZCA, and ZC. ZC is ZXA into ZA, ZXA minus ZA, then ZXB minus ZAB, and then ZXC minus ZAC. Right. So, this would be the case. So, then therefore, if I, so now therefore, now this is a 3 cross 1 vector and this is an 1 cross 3 vector. So, their product would be 3 cross 3 matrix, and basically the first row would be this into this into this into this, and basically the second row would be this into this into this, and then this term into this term, and then the third row would be this term into this term, this term into this term, this term into this term. And then of course, every term would be divided by ZXX dash. So, if I do all this and then if I do and collect out the term, so then ZABC would be ZA minus ZAX minus ZA into ZXA minus ZA. Okay, let us for the okay, let us do one thing, otherwise it is becoming very clumsy. So what we do is we will also term them something like this. We will also use some notation. So let's denote them, this one to be say Z, say A1, let's say Z B1, let's say Z C1. So this I call at ZA1, this I call at ZB1, this I call at ZC1, and say that I call it at ZA2, I call it as say ZB2, I call it as say ZC2, right. So I just term them. So this I term as ZA2, this I term as ZB2, this I term as ZC2. So then therefore, so now with this notation, this is just for the brevity. So with this notation, this matrix would be ZA minus ZA2 into ZA1 by ZXX dash, then ZAB minus ZA2 into ZB1 by ZXX dash, then ZAC minus ZA2 ZC1 by ZXX dash, then ZBA minus ZB2 into ZA1 by ZXX dash, then ZBB minus ZB2 ZB1 by ZXX dash, ZBC minus ZB2 ZC1 by ZXX dash, ZCA, then ZC2 ZA1 by ZXX dash, then ZCB minus ZC2 ZB1 XX dash, ZCC minus ZC2 into ZC1 by ZXX dash. So this is the final, ZABC matrix comprising of only one bundle conductor in phase A. Now we can also extend this concept in which there are bundle conductors in all the three phases. So let us look at that case. So now, so then therefore, now we are considering bundle conductors in all three . So what would be the case? The case would be something like this. So let us say that I do have 6 conductors So, there are 6 conductors. So, this is A dash, let us say that this is R dash, this is B dash, this is S dash, this is C dash, this is T dash. And these two conductors in parallel constitutes phase A. Conductor B and S in parallel constitute phase B. Conductor C and T in parallel constitute phase C. And so then of course this is VA, this is VB, this is VC, so this is VC, VB, VA. This is from with respect to the local ground and etc etc. So this is with respect to the local ground, this is the local ground. Right. So then, so now there are actually 6 conductors, 1, 2, 3, 4, 5, 6. So for these 6 conductors, we can write down basically the primitive admittance matrix, and from the primitive admittance matrix, then we can write down the admittance matrix. So if I write down the admittance matrix, then I can write down that VA, VB, VC, VR, VS, VT is equal to ZA, ZAB, ZAC, ZAR, ZAS, ZAT, ZBA, ZBB, ZBC, ZBR, ZCA, ZCT, ZRA, So I can write down that, okay, I can say that this is IA dash, IEB dash, IC dash. So let's say, just to note it down, so let's say that this current is IA dash, this current is IR, this current is IB dash, this current is IS, this current is IC dash, this current is IT, and this current is IA, this current is IB, this current is IC. Obviously, IA is this is from here, this is from here, this is from here, and of course here I can say that IA is equal to IA dash plus IR. Okay. So, and of course we know that VR minus VA is equal to 0. We also know that VR minus VA is equal to 0. We also know that Vs minus Vb is equal to 0, and we also know that Vt minus Vc is equal to 0. So, this we know. Now, with this we have to do now several things. So, now essentially in phase A I have to bring the current IA dash plus IR, in phase B I have to bring the current IB dash plus IS, in phase C I have to bring the current IC dash plus IT, and then here I also have to make these entries 0 0 0. I have to also use these three equations, I also have to use these three equations. So, let us see that how can I do that equation. So, from the first equation, right. So, this is the first equation. Now, this, so this is IA dash, this is IB dash, this is IC dash. So, now this I can write it down that ZA into I dash plus IR plus ZAB plus IS plus ZAC IC dash plus IT, and then IR. Now, I have added ZAA into IR, so I have to also subtract this. So, I can say that it is ZAR minus ZAA into ZAR minus ZAA into IA, IR, ZAS to IS, and I have also added ZAB into IS, so I also subtracted ZAB into IS plus ZAT minus, I have also added ZAC into IT, so I have to subtract it to IT. Now this quantity is IA, this quantity is IB, this quantity is IC. So then therefore I can write it down that ZAA into IA plus ZAB into IB ZAS minus ZAB into IS plus ZAT to IT. ZAR minus ZA into IR, ZAS minus ZAB into IS plus ZAT minus ZAC into IT. Say that this is equation 1. Say VB IT. So I can write it down ZBA into IA dash plus IR plus ZBB into IB dash plus IS plus ZBC into IC dash plus IT plus ZBR. I have added ZB into IR, so I have to subtract it. Then ZBS. I have added ZBB into IS, so I have to subtract it. Plus ZBT. I have added ZBC into IT, so I have to subtract it. So these set ZBR minus ZBA into IR plus Z. So this is the second equation. So similarly, we have to also look into the other 4 equations, which we will do in the next class. Thank you.